It is for me a great pleasure to welcome you here at Life Research. That is a laboratory located at the School of Architecture at McGill University. I'm Aaron Sprecher, I'm the director of Life Research, and I'm here with François Leblanc, who is a lead researcher as well as a research associate here in the laboratory. Our mandate is both in terms of developing high-end research as well as using this laboratory as an interface for educational purposes. At the core of this laboratory stands a Stratasys Connex 500 machine, and we were interested by the multi-material capability of this rapid prototyping technology. The reason why the Connex 500 is used on a 24/7 basis, it has to do with the fact that it's not only used in terms of producing some prototypes in our research, but it is also heavily used by other research groups across the university and especially the Faculty of Engineering and the School of Architecture. The Connex 500 is absolutely essential in our research.
The essence of a research is trying to combine computational methods of producing new forms that are lightweight, using less material, but also free form that are highly intricate in terms of manufacturing. Working with Connex 500 also allows a variety of material. Well, the material is at the core of the research here, and as an example, we're able to produce some material that are graded, and we can retrace the property of the material inside, and so we can test it physically. It's not just a model that is printed, but we can actually use as a functional input of our research.
So the Canadian Centre for Architecture is one of the prominent architecture institutions in Canada as well as in the world. Students are using the Connex 500 in order to develop new forms of prototypes. Currently at the Canadian Centre for Architecture, you can see some of the prototypes developed by our students being featured in an exhibition called ABC Montreal. For instance, what you see here is an example of one of the sites that has been approached. It's a metro station called Villa Maria, for which that team of students developed a skyscraper that would have a very non-standard but extremely effective structural envelope. So this is another prototype that investigates the nature of exoskeleton on the skin of a building. That prototype became the basis for the development of a tower for a multimedia company. None of those prototypes could have been produced without the technology of rapid prototyping, and I would even argue that most of them would not have been possible to produce without the multi-material capability of the Stratasys Connex 500. I would say that the Connex 500 and now Stratasys is our partner in many of our research and adventures in architecture. I do believe that the Connex 500 belongs to a new generation of technologies that will certainly transform the realm of architecture and architectural design and research.